So let us solve the first example. The first example I am taking is this way. Discuss the intersection. Discuss the intersection of the spheres S1, which is given by x square plus y square plus z square minus 2x plus 2y minus 4z plus 2 equal to 0, and S2 is equal to x square plus y square plus z square, then plus 2x minus 4y plus 6z plus 5 equal to 0. Okay, so this kind of questions we are going to solve about the intersection of different spheres, and different situations will be discussed over here. So the solution to this: as I told you, first you must find the centers and the radius of both the spheres. So for the sphere S1, we have the center C1 is equal to, we know that how to find the center coordinates. Just see the coefficients of x, y, z in the equation of the given sphere and divide it by 2 and change the sign. So first x coefficient is minus 2, divided by 2 is minus 1, and then change the sign, so it is plus 1. Then here coefficient of y is 2, so this will be minus 1. This is minus 4 divided by 2 is minus 2, so changing the sign, this is plus 2. And the radius is given by R1 is equal to square root of, as you know, u1 square plus v1 square plus w1 square minus d1. So this I can write as, here this is your u1, u2, u1, v1 and w1. So I can put that value here. Since it is a square, there is no problem whether it is plus or minus. So this is u1 square plus v1 square, that is minus 1 square, plus w2 square, w1 square is 2 square, minus d1. d1 is this, the constant term in the first sphere, that is 2. So this gives us, say, 1 plus 1 plus 4 minus 2. So it is 6 minus 2, that is 4, so is equal to 2. So radius of the first sphere is R1 is equal to 2. So I am writing R1 is equal to 2. So likewise, you find the center and radius for second sphere also. For second sphere, center is C2 is equal to, just look at these coefficients, divided by 2 and change the sign. So 2 divided by 2, 1, that is minus 1, then it is plus 2, then it is minus 3. Okay, 6 divided by 2 is 3, and changing the sign. And the radius, now I am writing directly using that formula, R2 is equal to square root of u square plus v square plus w square minus d. Here the d value in this second sphere is 5. So it is minus 1 square plus 2 square plus minus 3 square, u square plus v square plus w square minus d. D is 5. So it will be like this. And if you simplify, this is 1 plus 4, that is 5, 5 plus 9, so it is 14, and 14 minus 5 is 9. So this is square root of 9. And so the value of the radius R2 therefore is 3. So R2 is equal to 3. What is left? In this type of problems, always first find the radius, centers, and also the distance between the two centers. So also the distance C1, C2 between the two centers is, you know, by the distance formula. See, the center C2 is this, and center C1, which you written here, is 1 minus 1 2, 1 minus 1 2, and this is minus 1 2 minus 3. So you can have 1 x1 minus x2 square, so it is 1 plus 1 whole square plus this minus 1 minus 2 whole square, minus 1 minus 2 whole square, then z1 minus z2, so 2 minus minus 3, so it is 2 plus 3 whole square. Okay, let us simplify. So what you will get is 2 square, that is 4, this is 2 square, that is 4, plus minus 1 minus 2 is minus 3 square is plus 9, plus 5 square, that is 25. So it is 9 plus 4 13, 13 plus 25 is 38. Okay, and if you calculate the value, decimal value of this, it is approximately 6 point something, say 6.1 or so. Okay, so what do we have? We have C1 C2 is equal to 6.1. You can say C1 C2 is equal to 6.1. R1, the radius, R1 is equal to 2 and R2 is equal to 3. So what is the relation here? So therefore you can say C1 C2 is greater than R1 plus R2. This is 6.1 and this thing is 2 plus 3 is equal to 5. So what is the situation? When the distance between the two centers is greater than the sum of the radii, the two spheres do not intersect each other. So in this case, the conclusion is S1 intersection S2 is equal to 5. That is, two spheres, the two spheres do not intersect. Do not intersect. Okay. Let us take some interesting problem where the two spheres may intersect or touches. I am taking different situations. So second problem. So again, let me write the question in a different way. Prove that the two spheres S1, which is given by x square plus y square plus z square minus 4x plus 10y plus 2z minus 24 equal to 0, and second sphere, that is S2, x square plus y square plus z square plus 10x minus 18y minus 12z plus, let me rewrite this, minus 12z plus 46 is equal to 0. Prove that the two spheres are tangent to each other, externally. Also, in this case, find the point of contact, or you can say the point of intersection of the two spheres, the point of contact, and the tangent plane, and the equation of the tangent plane at this point. So try to understand this problem. Prove that two spheres S1 and S2, which are given here, are touching each other externally. That is the first thing. Prove that they are touching each other externally, and also find the point of contact. Point of contact means the point where they are touching each other. And at that point, you can draw a tangent plane to both the spheres, which is a common tangent plane to both the spheres S1 and S2. Okay. So first of all, let us find out the centers and radius for both the spheres. So for S1, I am writing the center C1. Whenever I write C1 means center of the first sphere. So just dividing this coefficient -4, 10 and 2 by 2 and changing the sign. So this will be what? -4 by 2 is -2, and changing the sign it is +2. Then it is -5. Then 2 divided by 2 is 1, so it is -1. And the radius R1 is equal to square root of 2 square plus -5 square plus -1 square minus d. D is this. For the first sphere, it is -24. So -24. So what will be this value? So it is 4 plus 25 plus 1 minus plus 24. Okay. So you will get square root of 54. This is equal to square root of 54. And if I simplify further, this is 9 6 54. So taking 9 outside of the square root, we'll get 3 root 6. Okay. So this is your R1. Remember this. Same way, we can find for the second sphere, for the sphere S2, the center C2 is equal to, let me check, yes, 10, 18 and -12. These are the points. 10, -18 and -12. So divide it by 2 and then change the sign. So it is -5, then plus 9 and 6. So it is -5 plus 9 and 6. Okay, fine. And the radius R2 is square root of -5 square plus 9 square plus 6 square minus d. What is d in the second equation of the sphere? That is 46. So this 46 is our value of d in that formula for finding radius. So it is minus 46. So simplifying, it is 25 plus 81 plus 6 square, that is 36, minus 46. So you just calculate this. 5 plus 1, 6 plus 6, yes. So it is 96, right? It is square root of 96. And this also we can simplify further. And it is equal to, 16, 6 and 96. So it is 4 root 6, taking 4 outside of the square root sign, 16 outside of the square root sign. So R2 is equal to 4 root 6. So this is the value of R2. Still we have to find the distance between the two centers, that is C1 and C2 here. This is C1 and this is C2. You know, using the distance formula, you can find the distance between C1 and C2. So also the distance C1, C2 is using that 2 minus 5, that is 2 plus 5 whole square, and this minus 5 and 9. So minus 5 and minus 9 whole square plus it is minus 1 and 6. So minus 1 minus 6 whole square. So this is the distance. And if you simplify, let us see what we are getting. So this is equal to 2 plus 5, 7. So 7 square. 9 plus 5, 14. Minus 14 square is plus 14 square. And minus 6 minus 1 is minus 7. Minus 7 square is same as plus 7 square. So it is 49 plus 49. I mean, this is 49. And 14 square is 196. This is also 49. And if you add up, what you will get is 49 plus 49 is this 9 plus 9. So we'll get 294. Okay, we'll get 294. Or yes, and can I simplify this as we did earlier? This is 4 and this is 3, 7. So 49, this is actually, I think it is 49 square into 6. 49 square into 6. Is it possible? What? Just a minute. And 294. So this is actually, if vectorize, it is same as 49 into 6, which is nothing but 7 root 6. So we are getting C1, C2 is equal to 7 root 6. Now look at the three numbers. C1, C2 is 7 root 6. R1 and R2. What is R1? R1 is this 3 root 6. Yes. R1 is 3 root 6. And R2 is 4 root 6. So it is clear that C1, C2 is equal to R1 plus R2. So I can write thus C1, C2, that is 7 root 6 is same as R1 plus R2. What is R1? 3 root 6 and 4 root 6. This is 3 root 6 plus 4 root 6, which is also 7 root 6. So the conclusion is, therefore, S1 and S2 are touching each other externally according to our condition. Okay, so this is the situation in this case. Let me explain by figure. So I have two spheres. One is S1 and another sphere, so S2, and both are touching each other externally. So if I take The center is here, C1, this is C2, C1, this is C2, and if we join this is 7 root 6. So S1 and S2. What we can do here is some additional thing which is asked in the problem, that also find the point of contact. We have to find this point at which the two spheres are touching each other. So I want to find the point P of contact, and also I want to find the equation of tangent plane at this point. So if I explain this way, suppose if I draw tangent plane like this, let me draw this. No, it is not. So this point, this plane is tangent. It is in 3 dimensions. This is not proper figure. Let me draw manually. So I can draw like this. A plane is somewhere like, it is tangent and it is okay. So I can join this way. There is a tangent plane which is touching both the spheres. Yes. So this is a common tangent plane, and we want to find the equation of this tangent plane. Just remember a very simple thing. The equation of tangent plane is very easy. Just take the difference of the two equations and you will get the equation of tangent plane. What is main and difficult part is how to find the coordinates of this point of intersection or the point of contact. So next aim is to find the point of contact. The point of contact. Okay. So what I am going to do is to find the coordinates of this. First, the equation of tangent plane is very simple, and that will use to derive the coordinates of the point of contact. So the equation of the common tangent plane, okay, let me call this plane to be pi, name of this plane, pi is S1 minus S2 equal to 0. Just remember, whenever two spheres are say intersecting, we can have a plane passing through that intersection, and that plane is given by S1 minus S2 equal to 0 because it is satisfying both the spheres. So what is S1 and what is S2? Let us go back and see what are the equations of S1 and S2. These are the two equations, and what you do is take S1 minus S2. So minus 4x minus 10x. So it is minus 14x, then plus 28y, and this is 14z. And then add these two also. So 40 plus 20, 60, and plus 10, that is 70. Okay. So S1 minus S2, you will get, if you check, is S1 minus S2 is minus 14x or let me explain there only so that you can understand. Yes, let me write down the difference here. For these two equations, I am writing here, the minus 4 minus, see, when you take s1 minus s2, this x square, y square, z square will be cancelled. What remains is minus 4x minus 10x is minus 14x. Then minus 10 minus minus 18, so it is plus 28y. Then 2 minus minus 12, that is plus 14z. And then this minus 24 plus 46, that is minus 46, is minus 70 is equal to 0. Okay, so this equation I am writing, and as the difference of s1 minus s2, so minus 14x, then plus 28y, what was that, plus 14z, and minus 70 equal to 0. You can see there is a factor 14 common, so I want to divide and simplify this equation by minus 1 upon 14. So multiplying this equation by minus 1 upon 14, you will get x minus 2y and minus z plus 5 equal to 0. So this is the equation of common tangent plane. So it is this equation. The equation of this plane I am writing here, x minus 2y minus z is equal to minus 5. This is the equation of this plane. You know how to find the normal from the Cartesian equation ax plus by plus cz is equal to d of a plane. Just simply the coefficients of x, y, z are the coordinates of the normal vector to the plane. That is, in this case, it is 1, minus 2 and minus 1. That is a normal vector. So I need that normal vector. You know what is the normal vector of a plane? A vector which is perpendicular to all the vectors in a plane. So this is a normal vector. So what is n bar here? That you can obtain from the coefficient of this this x, y, z. So 1, minus 2 and minus 1. 1, minus 2 and minus 1 is the normal vector to this plane. Now what is my interest is to find the point P, that is the coordinates of the point P. For finding this, what I will do is I will find the equation of this line joining C1, C2, and as you can see that this line is intersecting this plane at the point P, and I know how to find the intersection of plane and line, which we have studied also in our higher secondary course. So I can find intersection of this straight line and this plane. But how to find the equation of this line C1, C2? You know, to find equation of a line, you need just a point and the direction in 3 dimension. Remember, these all are in 3 dimension. So for finding equation of C1, C2, you know, it is passing through C1 as well as C2. Okay. So coordinates of C1, C2, you can use any one. Say, let me check what are the coordinates of C1, C2 we have written. Yes, C1 is 2 minus 5 minus 1, only 1 is sufficient. So I am writing here, it is 2 minus 5 and minus 1. The coordinates of this C1. Also the normal vector is this. So I can use this equation of a line which you can recall, r bar is equal to a bar plus kl bar. The vector equation of a line passing through the vector point a bar and having direction l bar. So l bar is our n bar here, and the point r bar is this a bar. Okay. Or you can also use that Cartesian equation in the form x minus alpha upon L is equal to y minus beta upon m is equal to z minus gamma upon n. You know, equation of a line passing through a point, say a alpha beta gamma, and having direction, say L bar, is equal to say L comma m comma n is given by this equation. This is the Cartesian equation, x minus alpha upon L, y minus beta. In our case, alpha, beta, gamma is 2, minus 5 and minus 1, which is this center, and the direction is this n bar, direction of the normal, because this line is also perpendicular to this tangent plane. So it is in the same direction as the normal of the plane. So we can write down the equation immediately using this C1 and this normal vector. So let me write some explanation. The equation of the line C1, C2 is given by, as I explained, x minus alpha. It is passing through, you know that 2, minus 5 and 1. So x minus alpha, let me write directly, or the equation for line C1, C2 is given by, let me write down this for your reference so that you can understand. The point C1 has the coordinates 2, minus 5 and minus 1, okay, and the normal vector n bar, which was 1, minus 2 and minus 1, okay. So the equation of the line C1, C2 is given by x minus this is your alpha, beta and gamma. So x minus 2 upon L, this is L, M and N. X minus alpha upon L is equal to y minus beta, so y plus 5 upon M, and z plus 1 upon minus 1 is equal to, say, k, where k belongs to R. So this is the equation of line C1, C2. Okay. As a result, I can write down the coordinates of any point on the line C1, C2, okay, is given by, you know how to find the coordinates of any point from this equation of the line this C1, C2. This is the line C1, C2, okay. So you can compare this with k. So x minus 2 upon 1 is equal to k, gives you x is equal to k plus 2. So the first coordinate is k plus 2. Then the y coordinate you can get by comparing this with k. So y plus 5 by minus 2 is equal to k, gives you minus 2k minus 5. And the z coordinate similarly is minus k minus 1 by comparing the last term and the k. So that gives me the value of x, y, z. This is your x. Let me write here. This is x, this is y, this is z. This is x, y, z coordinates of any point, arbitrary point on the line L. Let me explain what is this. So any point here or here or here, this arbitrary point is given by that expressions. So the coordinates I can write down immediately as x is equal to k plus 2, y is equal to minus 2k minus 5, and z is equal to minus k minus 1. Okay. So as we know that this line is passing through that plane, so it will intersect. So for some k belongs to R, for some value of k belongs to R, the line C1, C2 intersects the plane pi, whose equation we have written earlier as x minus 2y minus z plus 5 equal to 0, okay, at the point P, which is of our interest. We want to find the coordinates of the common point, that is P, in that figure. So just by putting the values of x, y, z in this equation, what I will get is putting x equal to k plus 2 here, we'll get k plus 2 minus 2 into y is equal to minus 2k minus 5 and minus z, that is minus k minus 1 plus 5 equal to 0. So that gives me, on simplifying, so this is k plus 2 plus 4k plus 10 plus k plus 1 plus 5 equal to 0. So k plus 4k plus k, so 6k, and 2 plus 10 12 plus 1 13 plus 5 18 equal to 0, which gives me k is equal to minus 3. So this is the value of k. For this particular value of k, whatever x, y, z we get, that are the coordinates of the point P. Okay, so I can write, therefore the coordinates of the point P are x is equal to k plus 2, that is minus 3 plus 2 is equal to minus 1. Y is equal to minus 2k minus 5. Putting k equal to minus 3, we get minus 3 into minus 2 minus 5. So plus 6 minus 5 is 1. And finally, I can get z. And z, which was minus k minus 1, by putting k equal to minus 3, so minus 3 minus 1, so 3 minus 1 is 2. So therefore, the point P is given by what? X is equal to minus 1, y is equal to 1, and z is equal to 2. So this is the point of contact. So point of contact. Okay. So fine, this way we can discuss intersection of two spheres. We'll discuss some more case in the next lectures. Thank you.